Hello students, this is Vishal Vishwakarma, Professor of Physics, Assistant Professor of Physics from TIT College Bhopal, and today I am discussing you a fruitful topic from your syllabus of Engineering Physics, which is polarization of light. So let's get started. As you see in the diagram, the polarization is a property of light that describes the orientation and oscillation of electric field. In unpolarized light, the electric field oscillates in all directions perpendicular to the direction traveled. In polarization light, these oscillations are restricted to a single plane, which can be linear, circular, elliptical. Polarization occurs when light filtered, reflected, or scattered. So basically, polarization is a property which describes the orientation of oscillation of electric field. Basically, the light is traveled with an oscillating electric field. Electric field means of I mean the in when light have a straight direction. Suppose the light travels in x direction, then along the z direction there have oscillations of electric and magnetic fields, which can be shown in your diagram. So this oscillations have oscillating electric fields perpendicular to the direction which it flows. Oscillating electric fields, and some same perpendicular to the oscillating electric field there is an oscillating magnetic field which is traveling in some direction. So this is not just two field. I'm not just this is not what just I'm talking about two fields. There are several fields which are perpendicular to the direction of propagation. The several fields are there. Several kinds of oscillations are there. So the polarization has something which is cut the every only cut those field which are not required, and if you put a polarizer, it makes delete the other perpendicular fields which are perpendicular to some electric field which are on z direction, and other perpendicular fields it in the other perpendicular field, like in someone in x direction and someone in y direction, he cancels it, and after cancelling it provides a singular field to you. As you see in the slide number second, you can see that there is a polarizer which is placed, polarizer 1, which is vertically placed, and if you put a strike a light on that, it cancels all other oscillation. Only vertical oscillations are available to go in that, and you got only vertically polarized light. Second one you see is a horizontal polarizer in this second figure, and when you see this, the horizontal polarizer cancels all the perpendicular fields, and only you will only get the horizontal field. It will only transmit the horizontal field. So this kind of effect is happening in polarized. When the light is polarized, it has only a singular electric fields or magnetic fields which are oscillating in some direction. So basically it is the kind of refining something. Suppose that we have a 1 kg of rice in which a 1 kg of salt is mixed. So salt, or let us some consider 1 kg of pulse is mixed. So 1 kg of, if you have to refine it, so you have to take a, a refiner, or it is said to be a uh, uh, something which is refining. So you have to take a refiner which has some pores which are in the size of the pulses. So if you put, but the size of the rises cannot go through it. Only size of the pulses can go through it. So when you put the mixture of pulse and rice in it, only pulses get, if you deviate it or if you wiggle it, so only you see that pulses can go and other things cannot go. Other rices cannot go. So only you got rice in your rice will not go, and pulses only go. So you refined it. you refined it, only you got rise in it. So it makes two different thing, different, it makes it different from two things different from each other. So you get rise one side, you get pulse one side. So refiner is work like that. Same the polarizer is working. Same the working of polarizer is something like that, in which you got only perpendicular, only on the direction of the field in which polarizer is settled to be. If polarizer is vertical, you got vertical direction field. If polarizer is horizontal, you got horizontal direction of field. So basically it is works like that. So I hope you have understand it, and if you have any doubt, you can query me through my email, which is Vishal Vishwakarma, z525z at the rate email gmail.com. And so thank you. It's a fruitful session for you, I hope. Thank you very much. Hello student, this is Vishal Vishwakarma, assistant lecturer in physics from TIT College, and today we are discussing about the topic, which is a scalar field. So basically, let's just started it. So basically, what is field? The field is a something which is a force. Yeah, it is a area covered by force, which you feel if you are under that influence, if you are under that the range of that force. So you feel that, you feel the force of that field. So basically field is a force area which you feel when you are in the range of that area. So scalar field, suppose we have a field, we in which we can only give the some numbers, only give, and not only give a single number, a scalar number 2 3 4 to that point. We can specify the scalar number 2 3 4 5 6 to that point, so that only and only that we have can and not have any direction, but only have a number to that point. So if you read some definitions on the internet or the various sources, which you can prefer, or would you like to prefer, that the definition which of a scalar field is something like that, which I read to you, is in your screen. That scalar field assigns a single number, a scalar, to every point in a region of space, meaning it represents a quantity with magnitude but no direction. Example includes temperature in a room, air pressure at different locations, where each point has a specific temperature and pressure value. So basically it's the same thing, that different, it is saying that it is in a region, we can specify any number to it. Suppose, for example, if in a region, if you specify a number to it, suppose you have suppose you have a one example of it. One example, if you take, so if you take one example of it, in which thing you use scalar field. So it is, best example is a temperature in a room. At every point of a room, there is a different temperature. If you select at every point, there is a different temperature. It has a minor difference, which is in a points region. I mean, if 70 degrees 25 45 degrees centigrade, so 45 at some the point next, if you're recording 45 degrees centigrade in one point, so at the adjacent point you record 41.6 degrees centigrade, 41.74 degrees centigrade. So this kind of value has been changed everywhere. So everywhere is changed in that region. So that is the best example of scalar field, which says that at every point you have a different fields, which provides you information that each and every point has some specific value of that force, of that heat, or of that cold, if you consider. So temperature is the best example of that. Suppose if you have a pressure, if you record a pressure in some specific region, and if you choose any point in that region, so you got a different location of that region, different pressure value. So it is one more example of it, that at different region of that space you get different pressure values in that region. So this is the second example which says that scalar field exists in such a way where we can specify a single number to that. There is no direction included in that, and there is nothing extra information included in that, just a number included in that. The one number assigned to every point. So you got so when you conclusively or when you collectively tell it, so it considered as a scalar field. So I hope you have understand. There is a gradient also, there is a picture of the gradient field in your slide, which says that in which direction your scalar field increases. So you have a direction of a scalar field, in which direction the maximum increase of the field is happen in which direction. So basically the gradient tells it then the maximum increase of maximum increase of any specific function. So if phi is a function, so maximum increase of that function is considered is tell us by the gradient of that scalar field. So you have the equation in your slide which says del phi equals to x I del phi del by x I del phi del by y as I del phi del by z. So this is a gradient which shows that the maximum increase of that field. So thank you, I hope you have understand. Okay, thanks. Hello students, this is Vishal Vishwakarma, assistant lecturer of physics from TIT college mains, and today we are discussing a topic of fruitful topic, which names as vector field. So if you read the definition of any vector field topic, it can be read as a vector field is a function that assigns a vector to every point in space, such as plane or three-dimensional space. It can be visualized as a collection of arrows, and where each arrow positions direction and length represent the vector at the specific point. These fields are used to describe physical phenomena like fluid flow, gravity, and electromagnetism. So as we discussed about scalar field, same thing has happened here, but there's little difference with that. If you select a region in a space, in that space you have a specific value at each point, and after that specific value you have a specific direction at each point. So at a specific value, a specific magnitude at that point, and a specific direction added to that point. So a scalar vector field work like that. If in your diagram, in your slides, you can see the two diagrams has been made it. First one is tells us the arrow pointed in some direction and is collectively is seeing as a square. And in second diagram you have a graph of equations, which is xy, and second is x upon x square plus y square, y upon x square plus y square. If it plotted at each and every point, you see a different direction. It has a magnitude, it has a number at that, as same as scalar field, in which here we have temperature there, but it has also the scalar direction also there. So the arrow has pointed some direction, so it has two information collectively in that region, where every point tells us some direction and every point tells us a magnitude also. So this kind of field is called as vector field. So the best example of vector field is considered as a fluid flow. If fluid is flowing through a pipe, so every position of under this pipe, you have a magnitude of force which is fluid is flowing, and also the direction which is flowing. Suppose it is flowing right, or suppose it is flowing left, so you have a direction pointed out at that point, and you have a magnitude at that point. Second example is gravity. At each and every point there is a different gravity force of gravity you feel. At each and every point you feel different force of gravity, but the gravity direction, the force of gravity has changes at points, but the direction of gravity is always towards the center of the earth. So you have all the points are acting towards or arrowing towards the center of the earth. So this is the gravity which works in that way. and so gravity is also a good example of vector field. Vector field. Gravity is a one kind of vector field. So I hope you understand it, and thank you for listening me. Thank you.